Advanced Math Lesson 38, Part A, is about the fundamental counting principle and permutations, and that's what these little cards are here for. If we have the letters A, B, and C on these cards, how many ways can they be arranged? And that's related to the fundamental counting principle. So I could choose A first, and then after that, I could have chosen B or C. I had three choices at first. And now I have two choices, so I'll put the B down, and then I have one left, so it goes there. Okay, at this point where I had two choices, I could have chosen the C instead, and then I would still have this one last letter that I had to use. At the beginning, before anything's been chosen, we had three letters. There are three possibilities for the first spot. After that, there were two possibilities for the second spot, and then only one left at the end. And so that's what these little diagrams are for at the top here for Part A. We have the letters A, B, and C, and they are all the different ways they can be arranged. Okay, and these are all permutations. A permutation is an arrangement of the members of a set, this was the set of the letters A, B, and C, in a definite order without repetition. Okay? This is a permutation. When we care about the order, we had three possibilities, three to choose from for the first spot. After one was chosen, there were two remaining to choose from, and then there was just one left for the last slot. When you multiply those, that gives you 6, which is how many permutations there were. And you can see that up at the top of your page. Okay, and this is the fundamental counting principle. If one choice can be made in a number of ways, and then after that choice is made, another choice can be made in B number of ways, then the total number of possible choices, the permutations, is A times B. Okay, so it's just stating what I set up here with this. You just multiply the number of choices for each slot, and that gives you the total number of permutations you can get. Now, if we had the letters A, B, and C to choose from, but we're allowed to repeat, like we had an unlimited number of A's and so on. After you've chosen one A, there's still another A. Then you have three possibilities for every slot, because I could have A, B, or C for the first spot. I could have A, B, or C for the second spot, and then also for the third. So that's just 3 times 3 times 3, which is 27. So you'd have many more options if you're allowed to have repetition. It was only 6 when there was no repetition, 27 when you're allowed to repeat. And that was just with 3 things. Look down here at example 1, and well, this one's different in a couple of ways. Okay, so how many 4-letter signs can be made from these letters, from the letters in this word, if no repetition is allowed? All right, so we have 4 spots, but we have more letters to choose from. None of these are repeated, so we have 1, 2, 3, 4, 5, 6, 7 letters to choose from. Okay, so in our first spot here, we have 7 to choose from, so that means I'm putting a 7 here. That's how many possibilities are there for the first choice. And we're not allowed to repeat, so after we've used one of those 7, how many do we have left to choose from now? 6. Okay. And then after that second one's been chosen, we have 5 remaining, and then after that we have 4 remaining to choose from. And these aren't saying we're going to make words with all of them. I forgot to say that at the beginning. It's just combinations of letters, but combinations are different. Permutations of letters. Okay, so 7 times 6 times 5 times 4. And then we multiply that. And that will be how many choices there are. So, let's see, 42 times 20, right? And that's 840. Okay. Now, what if we still have the same letters, we're still making a 4-letter sign, but now repetition is allowed? Well, that means we have 7 to choose from, we still have 7 to choose from, we still have 7 to choose from, and so on. So that is 7 to the 4th power. I guess I'll write it that way, but also we're going to find out how many that is. 2,401. Okay, no repetition. Cut off the screen, sorry. No repetition, 840. With repetition, 2,401 different choices, different permutations. Okay, so it makes a big difference whether or not you're allowed to repeat. Anyway, that's those. There are many more examples in the book that I didn't include in your notes, so you should take a look at those. But we're going to move on now to designated roots, which is part B. Totally unrelated to the permutations. All right, so I'm going to remind you first, you might see FOIL here, and we're multiplying things, and we're doing quadratic equations again. Just going to, up here in the top margin, I think, remind you about when we factor to solve equations. And we're going to do a real quick one up here. Let's see. Let's do x squared plus 3x minus 28 equals 0. And we're going to factor this and solve it. Okay? So we go like this. We know we need x times x to get the x squared. For the 28, we need factors of 28, but then they're also going to have to be 3 apart. We subtract one from the other to get 3. So 4 and 7. They're opposite signs. The larger one has to be positive. Okay, and you FOIL it in your head to make sure. X squared, there's the plus 3x, and then minus 28. Okay, and then we know the zero product property states that when you multiply two numbers and get 0, one of those factors has to be 0. So either x minus 4 is 0, which means x would be 4, because 4 minus 4 is 0. Or x plus 7 equals 0, which means x has to be negative 7, because then when you add those, you'd have to get 0. All right, these solutions, they're the solutions, but they're also called the roots of the equation, 4 and negative 7. And that would have been used sometimes. You would have seen that word, but we don't always focus on that. You're just solving. So you might not be thinking about the terminology, but these are roots. And so designated roots. Now we're going to be told what these numbers are, and we're going to write the equation. So we're going to work backwards. Okay? And if you want all of your coefficients and the constant to be integers, then after you've gotten the equation, you're just going to multiply by the least common multiple of those denominators. And then that'll cancel them out. I'll show you. So what we're going to do is what this says. We're going to write, after we're given the roots, x minus one of the roots, because that's what it was. Here was one of the roots. X minus that root times x minus the other root. Well, x minus negative 7 was 7. Okay, that's what we were doing there. And then we're just going to FOIL. We're going to multiply them. And then if we're supposed to have that all the numbers in it are integers, then we'll go ahead and multiply by the LCM. You're only getting one example here. The book has more, not much more, but one more. So you can take a look there as well. Okay, so our roots are negative 3/5 and positive 1/2. So we do x minus negative is plus 3/5 times x minus the other root, which is a half, equals 0. Okay, so it looks like near the end of one of the problems we had been doing, so now we're working backwards. So we FOIL x squared minus 1/2 x plus 3/5 x minus 3/10 equals 0. And we need to add the like terms. And for that we need common denominators. So this would be x squared, we'll make it tenths, so minus 5/10 x plus 6/10 x minus 3/10 equals 0. So x squared plus 1/10 x minus 3/10 equals 0. Okay, this is what they wanted. Quadratic equation, the lead coefficient is 1. So the x squared term has a coefficient of 1. So this is good. We have answered it. Okay, this is it. I just wanted to mention that the last bit up here says if you want all your coefficients and the constant to be integers, then you multiply by the LCM. So we would just multiply everything by 10 over 1. And if you knew up front you were going to want that, before you even added these two middle terms, like up here, I just would have multiplied everything by 10 over 1. And then when I was adding, I didn't have to get common denominators either. And I think I'll show you what I'm talking about. So our alternate instructions over here are going to be all coefficients must be integers. Okay, alternate instructions. Okay, so we actually did answer the question that was typed on your page. That was it. But if we were told all coefficients must be integers, from this step right here, I would have multiplied everything by 10. X squared minus half x plus 3/5 x minus 3/10. Just take it all times 10. Multiplying this side times 10 just still gives you 0. Okay. So 10x squared. Half of 10 is 5, so minus 5x. 5 into that's 2, so plus 6x. 10's cancel, minus 3. So then we would have 10x squared plus x minus 3 equals 0. That would have been our answer, which is what we get if we take 10 times everything here. It's just that would have been easier for you. So make sure you're reading those instructions well, just, so you can work efficiently and not do steps that weren't necessary. That's it. And again, there's another example in the book. Sometimes your roots aren't as pretty as ours were in this example. You may have complex numbers. The other example in the book, one of the roots was 1 plus the square root of 2. So you might want to take a look at that. But I was just trying to keep these streamlined so you only have the one example here. And then part C, overall average rate. There's basically your formula. Distance still equals rate times time, so the rate will be the distance divided by the time, but now it's total distance, total time. Let's take a look at two examples here. Okay, so Frank and Judy drive for 100 miles at 50 miles an hour. Then they drive another 180 miles at 60 miles an hour. What is their overall average rate? Okay, so to find this, we're going to find out how much time they spent on each of these. It doesn't tell us. And we know distance equals rate times time, so the time is distance divided by rate. Okay, so for the first leg here, the distance was 100 miles, the rate was 50. So the time for the first leg is 100 divided by 50, so 2 hours. And then their second leg, move this up a little, their second leg was 180 miles and 60 miles an hour, so that took them 3 hours. Okay, so their overall average rate is their total distance, so 100 plus 180 over their total time, which is 2 plus 3, so 280 over 5, and that is going to be 56 miles per hour. And that's it. We've answered it. Their overall average rate for the whole trip. And I've written more here than you would need to write on your papers, just so that when you're looking back at how we did it, you wouldn't be asking where the 280 come from. There it is. Okay, so you can write less work for these than I did in the notes. That's how it usually is. Okay. Now, next example, Frank and Judy driving again. Okay, so far it looks like the same problem. 100 miles, 50 miles an hour, then they drive 180 at 60. How fast do they have to drive for the last 120 miles, just the third leg, to have an overall average rate of 60 for the entire trip? Okay, so we know, when you have your formula up above there, overall average rate, they want to be 60, so that's going there. And we know the total miles, it's these 280 plus another 120, so 400 miles. I guess for now, I'll do what I was doing before. We had the original 280 plus the other 120. That's the total miles. And then the total time, well, so far they had 5 hours, but we don't know how long they're going to be driving for this next part. So I'll put times 3, because that's time of their third leg. Okay? So then we need to find out what that time is, and then that'll help us answer their question. So 2, 3, 400. Yeah, I'll do that first. Okay, so 60 equals 400 over 5 plus T3. And then I'm going to cross multiply. We have to get the variable out of the denominator. So cross multiplying, we have 400 equals 60 times 5 plus T3. 400 equals 300 plus 60 T3. Subtracting 300, we get 100 equals 60 T3. Okay, and then we would divide by 60. So that's 5/3. 5/3 of an hour would be T3. Okay, so an hour, oh wait, I don't need to find that. Let's look back at the question. Okay, I'm getting 5/3 of an hour, and how fast do they have to drive? Okay, So they're doing 120 miles, and here's my times. I do distance divided by time to get the rate. So you don't want to lose track of what your actual question was. I was going to convert this to minutes or something. Okay, so we had this, and now to get the rate, this is T3, by the way. So the rate for that third leg is going to be the distance of that leg, 120, divided by the time of that leg, 5/3 of an hour, which means we're multiplying by 3/5. Okay. 120 divided by 5 is 24. 24 times 3 is 72. I'm running out of room. So put it right there, and this is a rate, and it's miles per hour right there. Did it. Got it to fit, and we're done with the notes. Again, you want to look at the book for the other examples from those other two sections. And I'll see you later.